Hello. Anyone please okay, okay. So hello everyone, very good evening. Uh, yes. I hope I guess the mic is blocked. No worries. You can just respond over the chat box. Okay, so I hope most of us are students over here, right? Okay. So from which college or from which domain you're doing engineering, like tech or PE domain? Mechatronics. Okay. So you are doing tech in mechatronics, aerospace, PLC, okay. Mechatronics. Okay. Okay, so we have some biotech students as well. Okay, so from which year? Year? Okay, third year, second year, first year, second year. Okay, so robotics and automation. Okay, okay. So most of us basically from mechatronics department. Some of us are from ENC department, ECE department. Some of us are from CSE department, and students are basically from biotech as well. Okay, so we have some MTech as well. Okay. Okay, so second year, first year, third year. Okay, so talking about the BE or BTech, whatever you're doing, your engineering, your course in a respective field. So, being a student of CSE, okay, I'm audible. No voice breaking. It's not clear. Okay, just a second. Am I audible now? Hello? Okay. Okay. Yeah. Yeah. So we are talking about the students. Like most of us are from CSE department, EC department, and then some of us are from mechatronics, aerospace, and also biotech, and some are from MTech. Okay. Yeah. So moving ahead, if we talk about the thing what we are going to do in our actual course, okay, that is our humanoid robot. Okay. So talking about that, even if you don't have any prior programming knowledge, it's completely fine. But that's because while making any particular model, okay, it is basically your AI model, artificial intelligence or machine learning, or data science model, or IoT model, or the combination of all of these, that is your robots or robotics. The term is called as robotics. If we talk about the term robotics, so yeah, obviously programming is again a part of the robotics. Okay, because you will be deploying some of the sensors in your robots. You will be deploying some of the electronic components, some of the devices, some of the components, the camera, the arms and all. Yeah. So to move them, to make them as a working thing, you need to program them. Yeah, because if I talk about us as a human, we are the human beings. If I talk about us, currently I'm just speaking something. Yeah, even though I'm not programmed, but I am passing a message to my brain. From my brain, I am able to speak. Yeah, with the help of my brain, I'm able to speak. If I'm willing to write something in the chat box, basically I'm passing the message from my brain to the hand so that please write something on the chat box or inside the chat box. Basically, even though me as a human, I'm not programmed, but I have trained myself in that way. Yeah, but with respect to your robots, since it's the electronic part, you need to program them. You need to program them. So basically, moving ahead, if I'm just talking about the field, let us talk about the humanoid robot. Okay, just a normal thing, that is humanoid robot. So instead of saying the term humanoid, we just consider that robot. Every one of you might have seen this robot movie, Robot 2.0. Yes. Okay. Okay. So most of us, basically every one of us has seen this Robot 2.0. Exactly, I think that there is this Rajnikant, then again just working on that chip, red chip and green chip. That chip is nothing but we can say it's a microcontroller or microprocessor which is already programmed. Okay, then your chip is basically able to move the hand, speak something, say something, visualize the world, but there's nothing but seeing the world, then smell something. Yeah, how basically the robot, that chip is programmed in that way. So instead of saying the term humanoid, we're just talking about the robot. What actually robot means? A robot is something which can do some task. Robot is something which can move from A to B. Yeah, with A is something but the source, B is something but the destination. A to B. Robot can do your task. The task can be anything. It's nothing but it's obeying your order. Yeah. In the same way, if we talk about the humanoid robot, so yeah, humanoid robot. So basically, humanoid robot is something which appears like a human body. Yeah, it's nothing but we can see that thing. It basically just seems like a human body. Something but which has some head on it, then arms, then legs, then some upper body structure, some lower body structure. Yeah, something which looks like human body. We can say it's a robot. Yeah, but actually introducing a leg in a robot, in a human robot, is actually we can say it's like a very advanced. So instead, what we do, we just normally place a wheel over there. Why? Because we just want our robot to move from A to B or from A, like in direction to like any place to any other place. Yeah. Next thing is that we need something on the robot that the robot should look like humans. It's nothing but the face. Face might have some eyes. If we want, then we can deploy nose over there, the mouth over there, the ears if we want. Yeah, the neck part, we can say the arms part. Yeah. Again, talking about the humanoid robot, how we have males and females. He, she, his, her in the same way with respect to robots. Again, two different types. To differentiate with respect to their gender, is nothing but it is nothing but which looks like human, which looks like female. That is your male, and the feminine which looks like your female. If I talk about your human, it's nothing but your android. And second, if I talk about a female, it's nothing but parent. This is how the human and the this Android and the gynoid looks like. Android is nothing but the male, something which looks like a male. And talking about the second, this your gynoid is something which looks like a female. Talking about the places, the field, or where your humanoid robot are used. Basically, humanoid robots are used in each and every field. These are some of the basic examples which we have mentioned over here. But in actual, in today's world, robots are used in each and every domain, in each and every field, in each and every industry. And again, if I talk about few years ahead, like talking about 5 years, like after 5 years by 2025 or 2030, it is basically we are working in such a way that by 2030 we should be able to completely work on robots. Like we should actually reduce the robot. Yeah, Sophia. I hope everyone knows about Sophia. Yes, Sophia. Yeah. So Sophia, what you can say? It's an android or a gynoid? Yes, what we can say to Sophia? It's a human. Yeah, obviously gynoid, but it's nothing but Sophia. It's nothing but the female robot. So gynoid. So if we talk about Sophia, Sophia is able to do multiples and multiples of work, right? Sophia is able to move. Sophia is able to then say something, then speak something, hear something, and then after seeing and hearing, we can say Sophia is able to go for some critical thinking part or some actual thing that a human can do. So Sophia is able to perform each and every one. Obviously, we have came up like very move, like we have came very like we have advanced in such a way like in today's world that we have already made a humanoid robot, and still we are trying to go with some advanced part. We are trying to advance our technology. We are trying to update our technology. Okay. Humanoid robot is something your male robot that is your male appearance, and Garnet is nothing but which looks like your female appearance. Some of the examples of humanoid robots where humanoid robots are used for is basically research and space exploration, personal assistance, caregiving, education, entertainment, search, rescue, manufacturing, and obviously manufacturing is nothing but maintenance, public relation, healthcare. Yeah. Moving ahead, talking about the healthcare. If you talk about the healthcare during your COVID-19 pandemic, during your COVID-19 pandemic, so basically Wuhan, yeah, we can say we start from your Wuhan part, like basically from your Wuhan. So basically, in that at that time, the hospital basically was converted into a robot run field is for and for only for COVID-19, basically COVID-19 patients. Yeah. Basically, if I talk about the features, what that robot can do is nothing but the thermometry system to check the incoming patient's temperature and alert medical staff. Yeah, but whether it has some, whether the human has some fever symptoms, yes or no. Second thing is robots to guide patients with hospital admissions and provide necessary information. Then delivery robots to just supply the food or the machine or these medicines or whatever the patients want. Then the next is Harris AI platform to monitor patients' vital signs through those smart bracelets. So basically, we have a band-like structure which looks like a bracelet. So that bracelets are able to check your vital signs. And also there is one more thing they called as ring bonds. If you can just Google search it, smart bracelets and ring bond. With the help of these two things, like people were like the nurses or the ward boy or the doctors were able to actually check the vital signs, SpO2, the oxygen level, and all. Moving ahead, the agriculture part. So it's nothing but talking about the agriculture. Obviously, currently we as Indians we are basically trying to advance in agriculture. Yes, everyone is trying to advance in the agriculture field. If you just go to any village, just check out their equipment, the machines they are using. Yes, we have already advanced in the agriculture field. Again, we are trying to advance. Yeah. So I can say some of the machines, some of the robots which we have already deployed in agriculture field is nothing but automated harvesters. Yeah, that is your Marrow Markets fruit farm have been using drones by Table Robotics. Obviously, something but Table Robotics is the company name. That is just AI to identify the peak ripe for fruits. Then your weeding robots is the feed like the thing which are basically is something but we can say some pesticides part. Then autonomous farms is something for trying to just go for the advanced part of the farming area. So hospitality again, just moving about your talking about your for each and every task. Basically, we have just discussed about the delivery, food delivery. As we can say, in hospitality, yes, we have the food delivery robots. Talking about our own thing, we have created the co-robot again for the hospital, this medical part. Yeah, in the healthcare section for the medical part, we have already deployed the co-robot. You can search over YouTube, you can search over Google. We have deployed the co-robot. It's nothing but for your healthcare section, for your this healthcare, for your healthcare, and basically talking about healthcare, it is not only responding with respect to your healthcare, but you can we are also using those robots for hospitality because robot is nothing but it's a robot. Obviously, no sense of human being like the emotion part, the skin or getting infected. Yeah. So yes, the robot was able to work in the COVID-19 pandemic, already used in the market. So moving ahead, yeah, the evolution of the humanoid robot. So talking about your the concept of robots, not only humanoid robot, talking about the concept of robots, it was very far before this 1990s. That is your 19, I can say 19th century. We are actually talking about this robot, the concept of robot from the I can say from the starting of your 17th century. We can say, yeah. So till now we have developed a lot of robots. Okay, it's the thing. But today we are trying to develop a robot which looks like human, But previously we have already made some automated thing to which we consider it basically it's a robot. As you can see in the year 1495, Leonardo's robot, a very simple automation and armed knight. Nothing but a very small thing. Again, consider as the robot part. Moving ahead, 1774, you can see the draughtsman, the musician, and the writer. He also made the automated doll. In the year 1972, Vapor 84, Vapor 2, it's something called a musician robot. Yeah. Moving ahead, as you can see, the 1928 part, the robots, your Eric, Electro, basically, then your in the year 2011, we have Origo, then Poppy, Pepper, Sophia. Basically, there are n number of things which are already made in the market. And today, if I talk about the very advanced thing, as you can see, 2015 over here, Sophia. Sophia is nothing but given by the citizenship by your Arab, your UN, already got the citizenship over there. Yeah. Moving ahead, yeah. Okay, so talking about the global market of a humanoid robot. So before this COVID-19 pandemic, we can say the economic sustainability, then your research consulting over there, basically reached almost 13 billion. It is expected that by 2026 it will reach by 13 billion, and already in the year 2019 we have reached more than 5 billion. I guess it's somewhere around 7.6 billion. Yeah. So then it's nothing but basically today we are trying to deploy robots for each and every task. Okay, so we as a humans, I want to talking about the robots for us because we really don't use robots for our homemade thing, for basically for our home purpose. Right. Next thing is if I talk about the industrial part, because basically if I talk about our home old thing, what we're using in our home, I can say that everyone is using mobile phone. Some of you might be using Android. Some of you might be using iOS. That is your Apple, given by Apple iPhone. Yeah, there's something but your Android and the iOS. Android, we can say we have Google Assistant. iOS, your iPhone has Siri. Amazon, again Amazon has Amazon Echo. Is nothing but the concept of your AI, the concept of your machine learning, the concept of your deep learning. Yeah. So yes, we are already using some part of the human, some part of the human thing, some part of the the technology which is deployed inside the robots, humanoid robots or a normal robot. We are already using that. Next thing is we can say if I'm deploying a robot, arms and legs are totally different things. Okay, because we just for that we need some actuators, some motors, okay, some motor relays to program that. So we will just keep that part aside. Talking about a visualizing thing, we have the camera in our mobile phone. So in the same way, we can deploy a camera for our human robots or basically any robots. Okay, moving ahead, I want to say something. I want to say basically speaker can come into picture over there. I want to hear something. I can come over there. Yes, send something. Sensors are over there. So it's nothing but everything what we have already deployed, the same thing we are trying to deploy in a robot. And next thing is that we humans actually we want each of our tasks to be completed in very less amount. Yeah, and also we don't want to work at the same time. We want our tasks to be completed, but we also don't want to work on it. So again, we just need to adapt these technologies. So a concept you can say humanoid robot, which can again do your own task. Moving ahead, I just talked about these Google Siri, yeah, sorry, your Google Assistant, then Siri, then Echo, how, and basically why. So here, your AI comes into picture. Something called a speech to text, text to speech is something called the speech concept. Machine is something about whatever thing you are saying again and again, whatever thing, whatever word, whatever words, whatever characters, whatever alphabets you are saying again and again, saying again and again. So that will be recorded, and based on those recording, NLP, there is a concept called as NLP, natural language processing. So it will be applied. Yeah. So it's nothing but AI ML plays a very important role. If I talk about your robot vision, it's nothing but a robot can see how a robot can see. Even though we deploy a robot, it won't be able to see something. We need to just program in such a way that my robot should be able to perform some should be able to perform some task. Something but visualize. I can say robot vision is nothing but an OpenCV. OpenCV is nothing but a computer vision. Or CV2, OpenCV, or Python underscore Python dash Python dash OpenCV, or computer vision. This is a particular library which is made for a robot, or basically not only robot, along with your AI. AI, and then we can say for the advanced part, that is a robot. Your robot will be able to see, will be able to visualize. Imagining is something. Second part is image processing. How? Basically, here actually the concept of neural networks comes into picture, which can be deployed with respect to your deep learning, where deep learning is a subset of your machine learning, and machine learning is a subset of your AI. So, image processing. Talking about the backend part, we need the field, we need the concept of your machine learning, we need the concept of your neural networks, deep learning. With the help of which classifiers, with the help of something called as cascade classifier. There's something called as booster classifier, there's something called as hard cascade classifier. These are some of the model things, the algorithms pre-trained or made models which will help you to process a particular concept for a particular task. Process in the case is nothing but the detection part or the recognition part. Yeah. Moving ahead, again talking about this image processing. So what, how we can do this? I just said the robot vision is nothing but your OpenCV or CV2. Talking about the image processing, there is a concept, there is a field, there is a library module called as TensorFlow. Second is Keras. TensorFlow and the Keras. These are some of the very basic libraries which are again used. Okay, so I'm just saying that robot vision. So basically, robot vision is something, but it cannot only visualize or see. So in our actual course, we will be working on something called as face detection, face tracking. That is your real life face tracking with the help of the concept called as YOLO. What is OpenCV? How to use OpenCV? What is something called as edge detection? Yeah. Then trying to detect your face with the help of your Raspberry Pi. Raspberry Pi, because we generally work on Windows. Raspberry Pi works on your Linux, which is actually a platform for our IoT. How we can work on it? Getting my point? Okay, so moving ahead, imitation learning is basically it was used to train your robots in the year 1990s. Okay, in the years of 1990s, and now it's one of a part of your reinforcement learning. Yeah, talking about your reinforced learning is something. It's basically a type of a machine learning which are used for industrial part, basically your robots. Because if I say that I'm working on a machine, because in our actual academic, in our actual syllabus, we will be covering the concept of machine learning. We will be learning supervised learning. We will be learning unsupervised learning. The next thing is your reinforcement learning or reinforced learning. It's nothing but where you just need to pass a command, a rest, everything will be handled by the robot. Example of your Sophia, I just passed a command, do something, Sophia will be performing that task by training itself, by training its own self. Yeah, that is your reinforced learning. It is similar to observation learning, basically just trying to learn how to do some activities by visualizing others, and based on that decision, it will do its on its own. Okay. So yeah, moving ahead. Self-supervised learning. Again, as I said, we will be learning on supervised learning as well as reinforcement learning as well. It's nothing but in your self-supervised learning, it enables your robots to create their own training set, and based on that own made training set, the robot will be able to improve their performance. Example, if I say that I'm just saying something, yeah, some of you are also noting it down. Whatever I'm trying to say, what are the multiple concepts I'm trying to say. Yeah, because I can't just say everything in depth right now. Yeah, in the actual syllabus, in the actual course, we will be doing everything in depth. We will be covering each and every concept, each and every domain. For now, I'm just trying to say something in few limited words. Say something, but you are some of you might be noting down something, some key points, whatever I'm saying. So that if you refer it afterwards, you will be able to understand it better as the others. If I say that you have made the notes, if I see your notes, maybe I won't be able to get everything, but you, because you have made your own notes, you will be able to understand each and everything. It's nothing but improve your own performance. Okay. With your self-supervised learning, robots can scale large amount of unlabeled data in the lifelong learning manner and reduce the data set bias. Okay. If I say that the application where we can use this is nothing but an anomaly detection, object identification, recognition also we can say, detection also we can say, then avoiding obstacle is something but you are again trying to detect something. And then again trying to learn the new task from our own, and then performing, basically trying to improve the performance. Yeah, a very basic example is nothing but your watchpot developed by your kernel and your Stanford researchers. This uses a 3D sensors, a camera, laptop, as a laser pointer to detect normal inactivity. Yeah, very long before it was made. You can just search for normal human activity, you will get it. Next is multi-agent learning. Yeah. So if I say that I'm trying to work on a concept of agent, agent is a term which belongs to your AI concept. Can you see this? Here we just try to learn about your neural networks. We try to learn about the beauty part of your machine learning and AI. Here we try to learn about the complete of your AI. Sorry, complete of your machine learning. Again, machine learning complete. Now here we are trying to introduce the concept of your AI. Whenever we say the term agent, we just by default go for the AI concept. Yeah. So multi-agent system is a computerized system composed of multiple interacting intelligent agents that can solve difficult or impossible problems from an individual agent. Just trying to pass your data and trying to work on it, trying to learn on it, and trying to solve it. Yeah. Moving ahead, there's a concept called as robot navigation. Because me as a human, I have trained my brain, I know everything. Basically, if I currently am sitting at my home, if I want to go somewhere from my home to another place, I just need to pass a command to my mind. Okay, with respect to that, I will be able to work on it. It's nothing but I know that thing, so I will be able to move with respect to that. Yeah. So talking about a robot, is nothing about the robot navigation. We need to define the concept of your ROS, robots operating system. Again, talking about your robots ROS, it is your robot operating system. The name says robot operating system, but it is not an operating system. It is not an operating system. Okay. Basically, it is the middleware, or we can say middleware for your hardware and the software of the robot, whatever you're trying to deploy. Basically, it's a collection of the tools, libraries that aim to basically simplify the task of like creating some of the complex thing into some limited way, and with respect to that, perform a particular task. Okay. And if I say the term ROS, so again, I can say that there are two different terms in your ROS. Very first one is ROS node. Is nothing but ROS node. Node is nothing but the end, and is nothing but the place where our computation is actually done. Second is ROS core. Is nothing but the concept or the concept, the technology which is basically trying to connect me to those nodes, to multiple nodes. Okay, as you can see, a very small overview. It's nothing but you have your robot. I'm just asking my robot to move from A to B. I'm just asking my robot from move from A to B. Again, trying to sense the raw data, try to extract the particular information, whatever is required by your robot. Then with respect to that, localize the map, the area, the map. With respect to that, go for the path planning and then execute it by acting on it. Okay. So the concept we can say is see, think, and then act. Yeah, moving ahead. Yeah, okay. So what are some of the issues? If I say currently I'm sitting inside my room, bedroom, that is at the end of my room, I can say. So here the concept, here the thing is where am I? But if I place my robot, since I am aware of my room, I will be able to answer okay that I am inside my bedroom, so I can move easily. I can move from A to B or or vice versa. But with respect to your navigation issue with your robot, the question is where am I? Here I can say that basically we are trying to apply the concept of robot mapping. Yeah, robot mapping is something basically it will be like the ability of a robot to localize and construct a map. If I say that in my whole room, I'm sitting at the end of at end of my bedroom, so I just know about my room. I will be able to move from A to B or from any place to another place. With respect to your robots, the concept is called as robot mapping, which will be handled by your ROS. Where are the place related to me? So a concept may arise. So here I can say that I'm trying to localize the thing space relative to me. Localize the thing. So robot localization. How can I go to another place from here? It's nothing but trying to plan the path. So here the concept you can say it's a path planning. Yeah, again. I'm just saying that I want to localize the place. So obviously, we need to apply some algorithms like your KD search algorithm, your A algorithm, your RR algorithm, your yes, your RRR star algorithm. Yeah. So we are trying to apply the algorithm. Okay, just trying to get the sensor, with the help of your sensor, we will try to get the data, and with respect to that, we will try to resample it, and with respect to that, we will try to go with some motion update. It's something but how to, and also in this course, not only the actual part of a robot moving, but along with that, we will be also covering the algorithm, how to deploy an algorithm, how to work on any algorithm, how your machine will be able to work on any algorithm. Yeah. So and the sensor update. Sensor is nothing but here comes the concept of your IoT, Internet of Things. Okay, trying to work on the Internet of Things. It's nothing but how to just choose any sensor, how to deploy the sensor. What are the things you need to just work on a sensors? Yeah, the protocols, how to follow them. So we will be working on it. Again, sensors is nothing but actuator as well. We will also covering the actuators. Okay, I'm saying a resampling. So here we can say the concept of data and analytics comes into picture. Yeah, data analytics come into picture. So yes, we will be also covering the concept for you all, the data science concept for you all. Yeah, if I say that I'm just trying to resample data analysis means I will try to analyze the data. I will try to work on it. Yeah, I will just try to go for the data collection part. I will just try to visualize the data, plot the graphs and all that, how my machine is able to understand the thing, how my machine is able to move and everything. If I say that resampling, if I say your motion update, I can say the concept of your DA, data analysis, machine learning, data science comes into picture, which can be handled by the library called as your NumPy, your Pandas, your Seaborn, your Matplotlib, then your sklearn, your SciPy. These are some of the things, these are some of the libraries which we will be using. Moving ahead, again the same thing is nothing but your motion update, resampling, sensor update. Yeah. Next is your path planning. You're trying to plan a path, nothing but from A to B, how you will be moving from A to B. So the concept of path planning. Because with respect to your path planning, if I say that inside my room, a empty space for me will be acting as a grid for my robot. I guess I have it. Yeah, as you can see, empty space for me will be acting as a grid for my robot. Next is, as you can see, configuration spaces. That is all posts of your robot, free space, how to get the empty space, then your target space where my robot want to move, where my robot want to go. Obstacle space is nothing but if there is something in front of the robot yourself. Yeah. If suppose I say that there is something in front of me, Basically, I'm moving from my end where I'm sitting to the main door of mine. That is your main entry, main door of my home. Yeah. So in that case, walking on it, I can just normally go if my sisters comes in between, I can just normally stop for a while, or I will just take a right, or I will just take a left, or I will just move backwards and then I will move. Because I know how to work on it. But what about our robot? Robot doesn't know about this. So here we will be working on the concept of obstacle detection. That is your obstacles. Moving ahead, basically, it's the some of the robots companies that is your limited robot manufacturing companies. Yeah. So if I say that I am okay, so basically we are working on such like this much thing. We are trying to work on your AI concept. We are trying to work on your machine learning concepts. We are trying to work on your IoT concept, data science concept, data learning concept. Yeah. Actually, in the end, we will be deploying a robot which consists of all these concepts. So why to learn this? Yeah. Because whatever we will be teaching, because we believe in quality of the data or the quality of the thing, whatever we are providing, each and everything you will be able to deploy this in the real life example. Because here we are working about the robot, a very simple thing. We are trying to make a robot, so we are working on a robot. But if I say that I'm working on the concept of your OpenCV, something but which will help you to detect or recognize, I can say that recently we made a program that is called as your this robot I have told you. Also for 2020, we just made a program that is this your face mask detection. Face mask detection. 3 years back, we made a program, we made a model called as your sign recognition. Yeah. So with respect to this, your OpenCV plays an important role over there. How camera will be acting as an eye for my model, for my machine, for my robot, which will be helping me as a person, as a developer, or as a owner of a model machine to detect, to recognize. Face mask is nothing but obviously if a person is wearing a mask, then the person will be allowed inside the organization. If not, then no. If I say about the standard recognition, the deaf people who are not able to visualize, who are not able to hear, they can actually visualize. So yes, we can just normally show the sign. Yes, we can just normally show the sign. Either we are showing 1, 2, 3, or 4. Yeah. Moving ahead, if I talk about your machine learning part, it's nothing but we will be understanding concept of machine learning, how a machine learning engineer works. What's the concept of actual machine learning and how a machine learning engineer works? Because in the upcoming, like after 4 years, after 2 years, 4 years, 5 years, maybe after 10 years, the the work scope, the future scope with respect to all of this will be very high. All of this will be very high because you will be learning this thing like in your UG. Obviously, you are in your UG. Most of us are in UG, and some of us are in PG. Right? If you learn this concept right now, which are already used in the market, and some of the advanced things, some of the customized thing, very advanced thing, which we are deploying, which we are learning right now. Obviously, you will be able to build your resume, and the same thing if you go for a placement, at the like in as a friend of yours, your classmate, your batchmate is sitting beside you, he or she might get a package of 10 to 15 lakhs, whereas you can get a package of 25 to 30 lakhs. Who knows? There are n number of companies who are hiring such person who have idea about every field. Advancing thing is something different. If you know something about a respective field, then obviously you can add this in your resume and you can work on it. Yeah, so that's why we are basically deploying a lot of things. Even though we just want to make a robot, we're deploying a lot of things. And who knows, after a few years, you will be able to work any one of this company. Kinder System, Ubitech, then your Google. Google is hiring so much people from India itself. Honda, again Honda, I can say Honda is using very lastly in India. Samsung, people are using Samsung mobile phones. Samsung trying to deploy n number of things in the market right now. Yeah. So yeah, moving ahead. Yeah, the technology is what we will be learning. Uh, so we have already discussed about the AI, artificial intelligence, machine learning. I've said you about the IoT, Internet of Things. I've told you about the ROS, that is your robots operating system or robotics operating system. Next thing is kinematics. It's nothing but I'm just deploying some of the electronics because there is a concept called as embedded system. There is a concept called as embedded system. So if I say that I'm working on embedded system, something but a field which related to your electronic system, electronics part. Because if I say embedded system, basically it's a computer system, not a computer. It's a computer system which consists of consist means which is basically it's a combination of your processor or microcontroller. We will be considering microprocessor. Basically, computer processor, the memory, input output devices, peripheral devices, some of something called as timer, then your PWM, that is your module, and n number of things basically, which will help you to perform a very large scale with some of the mechanical device or the electronic device. So I am just trying to deploy the machine so that we can say a kinematic. So as if I say that I'm trying to perform some task, some real life like a walking part, a movement part, so physics comes into picture. Something but your kinematics, physics for your machines, prototyping, that how you can prototype a model is something about the sketching of the model, then modeling, yeah, fabrication is something about the outer body because even the prototyping plays a very important role in any market. If I just show you that I'm working on a robot and every internal circuits of the robots are visible, obviously it will create a very bad impression on anyone, right? If I say that Sophia, an example of Sophia, if every wires, every sockets, every boards which are deployed inside the Sophia, if everything is visible to you, obviously you won't love it. So the prototyping is something, but your outer look is important over there. In a very basic terms, AI, machine learning, discussed about it. That is nothing but your movement part, your sensing part, your visualizing part, your speaking part, your hearing part. Machine learning is dealing with the data, trying to train our machine. Embedded system already discussed. Internet of things, trying to use your motors, your actuators, your sensors. Powerhouse development is whenever I say powerhouse development, obviously while working on it, we need some power supply, right? We need some power supply. So here we can say we will be learning about the concept of the powers. Okay, the concept of the powers, like how to choose which component, like your battery, why to choose we will be actually using this lithium ion cells, why to use that. Yeah, we will be learning everything in depth. Okay, after that I will be saying that we are working on it. I will be saying that even though we have done with the selection of your battery, after that how to place it, what's the power management. Then there is a concept called, there is a device, the component called as your buck boost. Is something but which will help you to go with your DC to DC current, like direct current to direct current converters. Okay, so how to use that? If I talk about your embedded system, so sorry, your IoT. So we were talking about the sensors. Yes, we have sensors. What are different types of sensors? How to use them? How to go for the logic building of your sensors, and also the motors, the programming part. Then which wires to select? What wires to select? Which type of wire cables we will be using? Okay. So then your robotic operating system already, if I talk about the robotic operating system, so in this case, we will be saying that we are working on it. Okay. So we will be trying to install the ROS because there is a self-customized ROS with us. We will be using it. We will be installing, we will be implementing it, trying to simulate it. Yeah. And after that, after simulating, yes, we will be implementing, we will be deploying in a robot. Okay, then you're discussed about your AI. If we're talking about your AI, we have discussed about the face detection, tracking, YOLO, then image, reading the data from the image, then image resizing, converting the image, and everything. Yeah. After that, if I talk about integration of risk, yeah, sensors is something about your IoT concept. Yeah. So this is how the robot at the end will look like. Talking about this, even though we are deploying this, so here we just need to place, we first of all need to design it. We need to place a yaw. We need to decide the pitch, the degree of freedom. Yeah, talking about the degree of freedom is nothing but if I say that I want my particular robot to move, so there is a concept called as degree of freedom. Okay, it's nothing but basically it's a mechanic. It's a mechanics we can say. Basically, the degree of freedom is nothing but it is equal to the number of independent displacements, number of motions, like in which way it will be work. Okay, If I talk about the robot, if I say that my robot have some two arms, then I will be saying the degree of freedom will be doubled. Yeah, so a very basic concept. The actual concept of degree of freedom, because degree of freedom is required, it's very important for your robot. So talking about a degree of freedom, we will be discussing about it later on in our actual academy. Yeah. So next thing, if I talk about your then the talking about the prototyping, so something about the manufacturing or operations, such as we will be saying this the drilling concept, the building concept, how to cut those components, the shouldering, the grinding. These are the things which we will be doing. Yeah. And at the end, we will try to integrate all the things in your software, and we will be checking your hardware. And at the end, we will be testing our final output. Okay, and after that we will disable the robot. Okay, so yeah, here's the thing, the skills you will acquire: designing and the product planning, that is your model based development, system engineering, data visualization, embedded systems, concept of your sensors, motors, microcontrollers, microprocessors, actuators, and etc. OpenCV, then integrating your software and the hardware, then the power management, how it will work. As you can see, the course covers the modern analysis, control, and designing of humanoid robot with programming systems, including sensors, servo motors, power management, integration of IoT, AI, ML. But along with this IoT, AI, ML, we will be also covering your data analysis, your deep learning, and your data science concept. So this course will introduce students to the concept of terminology, state of the art development, energy conversion, and the storage options, modeling, analysis, system integration, and basic principle of vehicle controls, and many. So the projects we will be covering: face detection, face tracking, image processing using a OpenCV, mapping using ROS, that is a ROS, humanoid robot design and development. As I already said, here we are just learning the concept. We will be also deploying it. We will be also deploying it. And the same concept, same logic, you will be able to deploy in the upcoming projects. If you are willing to make your own project, then yes, you will be able to deploy. Then obviously, I have already discussed about the opportunities what you will be getting. As you can see, a job opportunity for students after this course: robotics process automation engineer, software development engineer, ROS, and R&D robotics engineer. Yeah, these are some of the projects. This is the robot, how it can work: recognize, face, and interact, autonomous navigation, hand movement and gesture, face tracking. These are some of the robots which we have already deployed. The very first is the Pro robot. Second is the which we have deployed and got praised by Israel. Then the Kavach, the very first is Kavach for Indian Navy. Then the robot which we made for Mahindra. This is the actual concept, the software logic for the chicken farming. That is the Darway, the again the robot. So yeah, these are some of the projects which we have already done. So talking about these benefits of the internship, obviously you will be getting the certifications. Like you all will be getting the certificates. Basically, it's a course of 10 days, and per day we will be going with 6 to 7 hours. So yes, we already discussed about the benefits of the program, and yeah, this is our official website. And rest I will hand it over to Sir. Yeah, and again you can just contact us on this number. Hello, sir. Yeah, okay. So guys, I hope everyone is clear. Yes, whatever we have discussed, any doubt, any queries with respect to that. Yeah, so obviously we've been covering a lot of things, and there's a very huge opportunity ahead after this course. Okay, so yes, actually it will help you a lot with your overall development, not only with this robots part, but with your overall development. So, sir, are you there? Hello. Hello.
Hello everyone.
Yes, sir,
Hello.
yes, sir, you're audible.
Okay. Yeah, Amit, can you share the screen, please? Hi, very good evening to all of you. I hope like you like the concept and the opportunity in this field, the humanoid world. As you all know, like after this COVID, we understood the requirement of this technology in the market, right? This product, like you can see, the electric vehicle, autonomous vehicle, these things are in trend because this the robot, which is not in our daily life, but it can be now because in hospitals, in hotels, in many industries after this COVID, they have deployed to remove the human interaction to get the work like a bit more efficiency, more accuracy. So many things are there. So you can see like many companies have started developing this product, including the Tesla, Hyundai, and many companies are there in this field. So as like we are getting the opportunity, but students are not having the knowledge of integration of multiple technology. There's some students who are very good into data science, some are good into machine learning, some are good into IoT. But when it comes to integrate all this technology, it is very difficult because you have to make all the device to communicate with each other, right? So for that to work only, we are coming with one of the India's first winter camp on humanoid robot design and development, where the students are going to manufacture complete robot, 5 feet tall robot, which is from scratch to final product. And the students are going to have the knowledge of all this technology with integration of everything. And here, like students are going to develop a robot which will have the feature of autonomous navigation. For that, they will be learning the ROS, the robotic operating system. Then there will be a human interaction also. It can recognize the face of the human. So there will be lots of advanced sensors which is going to integrate with a controller. And you guys is going to see the robot by your own hand. The robot which you are going to develop, which will have all these features. So this is a 10 days of program which is going to happen in around 9 cities of India. And in North is only one center, that is Lovely Professional University, where it is going to be happen in the month of January, which is going to start around 17th of January. And in this 10 days of program, you are going to build this robot with all the technologies you are going to build, you are going to integrate, you are going to learn by under the experts. And our expert, they have like already deployed this robot in many hospitals. They have like got the appreciation from many government of state government regarding this particular project also. So it's a golden opportunity for all of you who are interested in this particular domain, because this is not only limited for particular branch. You can like enroll in this particular program if you're from CSE, from electronics, from mechanical also, from instrumentation, from robotics and automation, mechatronics. So this domain is open for all the engineers who are into the market. So I prime skill under the experts from the industries, all like experts from different domain. They are connected with us to provide insight of the industry to the students. So to get a package of 3 to 5 LP is not a big deal. If you want to get something which is beyond 20 lakhs, 10 lakhs, then you have to get something, a knowledge of the product, not only the particular branch of technology, where you can integrate multiple things. And the technology which you are going to learn here, you can also implement on the like aero models, like for the autopilot concept. You can also apply in the autonomous vehicle for self navigation, self parking and all. So multiple things are there. So right now, like the seats are only 70 for the LP center. So if you are interested, you can enroll or you can visit our website. You can get the entire information over there. What all project you are going to do, what kind of certificate you will be getting, what technology you are going to learn, and what all concept related to humanoid robot you are going to build by your own hand. You can develop your portfolio. Will help also for that. How you are going to write these things, the project you are going to do here in the portfolio. So this robot will be kind of very advanced. Okay, 5 feet tall, which will have number of features as you can see in the screen. Okay, this robot, and as I discussed, there are lots of job opportunity. The competition is very low in this particular domain because still like the people are not knowing the importance of this product. As you know, the even the global market is going to be increased at a great level after this pandemic due to this like a requirement of human interaction. So this is a golden opportunity for all of you, okay, which is going to happen like only one center in North India, LPU. You can come, you can enroll yourself, and you will be getting two free courses also along with this. Because as we know, many students from first year, they are also interested to join. So if they want to join, they must have fundamental knowledge of coding, then they must have the fundamental knowledge of product design. So all these things will be available along with this course. So you can have like this course in the online mode only. The total charges for this program is only 7,000. And if you want to book your seat, you have to pay 1,700 to confirm your seat. The remaining like amount you can pay on the first day of training in the offline mode also. So the links will be available in the chat box. And the student who attended this webinar, they will be also getting a certificate for this webinar. And the remaining information, I'm sorry, remaining information will be shared by like your coordinators or industrial experts. They will share with you in the chat box links and in the WhatsApp group also. So if you want to come with a group also, you can make your group. Okay, you can participate in this particular domain. And apart from this, like after learning this technology, you can like attend many competitions like the Mars competition also, where you can design a buggy which can move in the autonomous manner. It can like move to different location. You can track the path. You can check the 3D mapping. You can create the 3D mapping of the environment after learning all these things. So once you are able to create a system up to that level, you are eligible for many international competition also, where you can make a robot in a group. You can participate. You can get job opportunity like in many you can say space organization like ISRO, NASA, and many places are there. So it's like a kind of a start for you guys. Okay, so you can book your seat as soon as possible. And if you want to know the process of enrollment, you can watch the previous video. Amit, can you play that video? I think audio is not available with this video right now in your system. You can share the link of this video with the students so they can go through it and they can understand the process of enrollment. So for the remaining information, you can please contact to like your LPU coordinator also, and like experts from iPrime skill, they will get in touch with you all. Only 70 seats are there. The reason behind it is going to consume lots of advanced sensors and the devices, motors, many things are there, which is not easily available in this country. You know, there's a global shortage of the chips. So that's the only reason we are keeping limited seats, because we have to provide this facility to another center as well. So only thing is very expensive product, this humanoid robot. With a small error, also a small power management issue, we may damage the lidar, sonar, many advanced sensor. So because of that reason only, we are going to keep only 70 seats. First come, first serve. Okay, the seats is going to allot in that manner. So thank you so much everyone for joining this wonderful session. And there's an opportunity for refer and earn also. You can visit your dashboard. You can get the entire information over there. For remaining information, be in touch with like your coordinators from LPU and iPrime skill. Okay, they will provide you the remaining information about this upcoming program. One of the greatest program in India, which is going to happen mostly in the January and Feb month across the India in 9 cities only. So thank you so much, and thank you team RISC, okay, for organizing this webinar. And the remaining information about the certificate and all, they will provide to you. So thank you everyone. Thank you for joining this session.